Kia ora Year 13 and Year 12. I'm going to start going through this year's complex numbers assignment, and I'm starting with the excellence questions. This video will probably have questions 1 to 3 in it, and I'll do the rest later on this week. So the first question is one where we're told we've got a quadratic equation and it's got 2 roots. We have to prove that if one root is twice the other, then 2b squared equals 9ac. So this question is one where most of the people in my class got full marks, but a lot of you did it in a pretty inefficient way. I think by far the easiest way to solve this problem is to use the results that we have about the sum and product of the roots of the quadratic. Now, if you've forgotten about those, there are 2 more videos down here from me that go through that really slowly. This one, which is called Level 2 Algebra, Sum and Product of the Roots, is done pretty slowly, and this Scholarship Calculus Building Blocks one is done a little bit faster. But the results tell us this, that if I've got ax squared plus bx plus c equals 0, then negative b over a is equal to the sum of the roots, right? Where b and a are these coefficients here, and c over a is equal to the product of the roots. So in the question we've got here, we can use this directly. We've got one root twice the other. So we're going to look at what that means for the sum and product and hopefully easily show that 2b squared equals 9ac. So let the roots be alpha and 2 alpha. That means that alpha plus 2 alpha is equal to negative b over a, or 3 alpha is equal to negative b over a. And alpha times 2 alpha is equal to c over a. That gives me 2 alpha squared is equal to c over a. Now when we're doing a proof, always look at where we're trying to get to. And in this case, we're trying to show that 2b squared has to equal 9ac. You'll notice that there's no alpha in that equation, right? Obviously, because we're trying to show that it doesn't matter what the roots are. If one is twice the other, then this condition will be true. So what we're looking for is a way to eliminate the alpha. You can see here that I've got 2 alpha squared. So I could write this one as alpha squared is equal to c over 2a. Here, I'm going to square both sides and get 9 alpha squared is equal to b squared over a squared. That would give me alpha squared is equal to b squared over 9a squared. We can put those two things equivalent to each other. B squared over 9a squared is equal to c over 2a. Now I have 2a b squared is equal to 9a squared c. We know that a is not equal to 0. Well, we can assume that a is not equal to 0 because, let's have a look. If it doesn't say that, right? But if a were equal to 0, this wouldn't be a quadratic. So I'm dividing through by a, and I get 2b squared is equal to 9ac as required. Or, if you like it better, you can write the little square box thing. Okay, so that's that question done. The other way to do it, which is one that lots of people in my class did, is to figure out that x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And so the big root will be the one with the plus. So then we have negative b plus this. This has to equal negative, which one? The big one is twice the small one. So it's 2 times negative b minus this. And look, well done to some of you who worked that through. I think that method's much more likely to give you mistakes. So I would always choose the sum and product of the roots way to solve this problem here. But as you know, it's all about finding a good way that works for you. So it's fine if you did it this way. It just is going to take up a little bit more time. Okay, the next question is one where we have to find a complex number that satisfies this thing here. Right, and they've prompted you to substitute in x plus iy. Now that's almost always going to be a good strategy, even if you're not told to do that. So in this case, what do we get? Well, we've got 1 over x plus iy plus 3 over x minus iy is equal to 2 plus I. Several ways to go here, but I cleaned up the left-hand side first by doing this. So I get x minus iy plus 3 times x plus iy is equal to 2 plus I. That gives me in the numerator 4x minus iy plus 3iy, so plus 2iy. I really don't like putting that I in the middle. I'm going to write that as 2yi. And in the denominator, I get x squared here. These go, and then I have plus y squared is equal to 2 plus I. Next up, I multiplied both sides by the denominator to clear out the fraction. So we had x squared plus y squared times 2 plus I. Now sorting out the right-hand side first, we have 2x squared plus 2y squared plus x squared plus y squared I. So I'm not fully expanding that. In fact, I don't really know why I expanded the first bit, but I did. Now we're going to match up the real and the imaginary parts. So for the real part, we get 4x is equal to 2x squared plus 2y squared, or 2x is equal to x squared plus y squared. So that's all I can do there for now. So that's matching my real part. And matching the imaginary part, I get 2y is equal to x squared plus y squared. So we look at this, and we look at this, and we say, well, that must mean that 2x is equal to 2y, which gives me x is equal to y. So now we have this condition to solve those two simultaneously. And that means that I can take this and I'm going to substitute it into either this one or this one. So we'll have 2x is equal to x squared plus x squared. So what I'm doing here is I'm eliminating my y in here. So I've got x equals y here, and I've got a y here. I'm going to replace that y with x. That gives me 2x is equal to 2x squared. Now be careful not to get rid of any solutions. Solving that gives me 0 is equal to 2x squared minus 2x. I can divide through by 2. I get x squared minus x. 0 is equal to x times x minus 1. Okay, so that's telling me that x is equal to 0 or x is equal to 1. And we know that y is equal to x from up here. So y is equal to 0 or y is equal to 1. That gives me, what I have to find out here is what's the solution z that satisfies this complex number. So we always go back and we check. All right, so this is telling me, just applying this, that z is equal to 0 plus 0i, or z is equal to 1 plus I. But my initial equation was 1 over z, right? And that's not defined when we're dividing by 0. So we reject the solution and we say that z is equal to 1 plus I is the only solution. Now I can check that back. Remember, we're looking at 1 over z plus 3 over the conjugate of z. So 1 over 1 plus I plus 3 over 1 minus I. We want to see what that would give us. Well, we'd get 1 minus I plus 3i. And that would give me 4 plus 2i divided by 1 plus 1, which gives me 2 plus I. So you don't have to do that. If you had time, that might be a good thing to do. So we've checked that that solution works. Right, so there's only one solution for that. Right, quickly moving on to question 3. So question 3 had no complex number stuff in it, but it's quite a mucky question. So I'll just clean up some of this. As usual, I want you to have a go at these before I go through them. So try this question. There are a few different ways to work with it. Let me just get rid of this. You can see that we've got 3 fractions, right? So I decided just to stick with it all on the one side and to get a common denominator. One thing to remember with common denominators is that you are looking for the lowest common multiple. So we don't need to have 2x squared here. In fact, we don't want it because it's going to muck things up. My lowest common multiple is just going to be 2x times t minus 1. Right? We don't need to be timesing out by that x. What does this give me? Well, I get 2x times x minus 1 minus x plus 1 times t minus 1 plus 2 times t minus 1. And if it's equal to 0, so we know that x can't be equal to 0, all we care about is the numerator, right? So we can multiply both sides by the denominator. That leaves me with 2x squared minus 2x minus tx plus t minus x minus 1 plus 2t minus 2 equals 0. It's a 1 in there. I've been really careful with this minus sign here because I can see that that's going to really muck things up if I stuff it up. So I get minus tx minus t plus x plus 1 plus 2t minus 2 equals 0. So we're just getting a big messy quadratic here. So next up is to clean this up. Well, we've got 2x squared, tick off as we go. Now I've got plus x. Now let's see what x coefficients we've got. Well, we've got 1, and then I've got a minus t here, and I've got a minus 2 here. That looks right. Okay, and then my constant is going to be plus 1 plus 2t minus 2 minus t equals 0. Now, you don't have to write that line out, but I saw so many small mistakes in this question that I think some kind of system to just make sure that you're getting all your terms as you go is worth it. Cleaning that up finally gives me 2x squared plus x times negative 1 minus t plus t minus 1 is equal to 0. This is not the most exciting of maths problems, I got to say, but it does check that you can work carefully with stupid coefficients. So now I'm going to put that into the quadratic formula. So x is equal to negative b, so negative 1 minus t, plus or minus the square root of b squared minus 4 times 2 times t minus 1 divided by 2a, which is 4. That gives me 1 plus t plus or minus the square root of, well, this expands to give me 1 plus 2t plus t squared minus 8t plus 8. And we're hoping that that's going to turn out to be a nice square number. We get 1 plus t plus or minus t squared minus 6t plus 9 over 4, which gives me 1 plus t plus or minus the square root of t minus 3, all squared, divided by 4. So I get 1 plus t plus or minus t minus 3 over 4. So working those out in turn, I get 1 plus t minus 3 over 4, or 1 plus t minus t plus 3 over 4, which gives me what? Let's see, 2t minus 2 over 4, or this is nice, I get 4 over 4, which equals 1. So this one here will be t minus 1 over 2, or 1. So those are my two solutions for x. And just checking that nothing goes wrong. I'm running out of time to do that, but they both looked fine to me. Okay, so quite a lot of work in there, but not much brain. So my least favourite kind of excellence question, but I still think it's a good one, because all it's really testing is that you are very comfortable with quadratics. But the other thing where people really did go wrong, as I said at the start, was in getting a common denominator here. Okay, so it's just going to be 2x times t minus 1. Thanks for watching.